Hey everybody, it's Jenny from Norman S. Wright. Since we were talking about AMCA 99 last week, I thought we would continue on with the standard and talk about another topic in AMCA 99, spark resistant construction. Let's get started. AMCA Standard 99-16, Section 8 is titled Classifications for Spark-Resistant Construction, and it covers both fans and dampers, but we're just going to cover fans today. The section begins with a statement that fan and damper applications may involve the handling of potentially explosive or flammable particles, fumes, or vapors. In these applications, the system construction should use components to ensure safe handling of these potentially flammable airstreams. Let's make a little room. Spark-resistant construction, SRC, is intended to minimize the possibility of any two or more fan components to generate sparks within the airstream by rubbing or striking during the operation. The standard applies to centrifugal fans, mixed flow fans, axial and prop fans, power roof ventilators or PRVs, and dampers, which I said we're not going to talk about today. So let's slide this out of the way and talk about the spark-resistant constructions. The standard defines three types of spark-resistant constructions, type A, B, and C, where A is the highest degree of spark resistance and C is the minimal level of spark resistance. So let's start with type A. Type A construction specifies that all parts of the fan in contact with the air or gas being handled and subject to the impact of particles in the airstream shall be made of non-ferrous material. Ferrous shafts and hardware exposed to the airstream shall be covered with non-ferrous materials as well. For fans, this means that the impeller, bearings, and shaft are adequately attached and are restrained to prevent a lateral or axial shift that might make components touch. So what does this look like? Well, the entire fan will be constructed of aluminum, including an aluminum shaft seal. If needed for your application, you can also get felt, neoprene, or ceramic shaft seals. This is going to be the most expensive of the three types of spark-resistant construction. Okay, let's slide this up and talk about type B construction. Type B construction specifies that the fan shall have a non-ferrous impeller and non-ferrous ring about the opening through which the shaft passes. Ferrous hubs, shafts, and hardware are allowed, provided construction is such that a shift in the impeller or shaft will not permit two ferrous parts of the fan to rub or strike. Just like in type A construction, steps must be taken to assure that the impeller, bearings, and shaft are adequately attached or restrained to prevent lateral or axial shifts of these components. For type B construction, fans will be constructed with an aluminum impeller and rub ring. A rub ring is placed at the opening of the housing where the shaft passes, preventing contact of the steel fan shaft and the steel housing. Type B construction is in the middle for both spark resistance and cost. Let's move this out of the way and look at type C construction. Type C construction specifies that the fan shall be constructed so that a shift in the impeller or shaft will not permit two ferrous parts of the fan to rub or strike. For type C construction, fans will be constructed with an aluminum inlet cone and rub ring. Type C is the least expensive of the spark-resistant levels. So let's move this out of the way and look at the notes that are included in the standard. Note number 1 says that no bearings, drive components, motors, or other electrical devices shall be placed in the airstream unless they're constructed in a manner that the failure of that component cannot ignite in the surrounding airstream. Note 2, the user shall electrically ground all fan parts. Note 3 states that for the standard, non-ferrous material shall be any material with less than 5% iron or a material that has demonstrated ability to be spark resistant. We're going to come back to that in a minute. Note 4, the use of aluminum or aluminum alloys in the presence of steel that has been allowed to rust requires special consideration. Research has shown that Aluminum impellers rubbing on rusty steel can cause high-intensity sparking. You're going to come back to that one as well. Note 5 says all structural components in the airstream, including non-metallic materials, must be suitable for conducting static charge to ground safely to prevent the buildup of electrical potential. So basically, these notes acknowledge that there's more to spark resistance than just keeping the ferrous parts away from each other. I do want to move this up a little bit and talk about note 3 and 4. Truly non-ferrous materials that contain no iron exist, but they tend to be extremely expensive and hard to obtain in a form that you can use for manufacturing fans. This is why aluminum is the most frequent alloy used due to its cost and manufacturability. But as pointed out in note 4, aluminum is in close proximity to rusted steel. The aluminum rubbing against the rusty steel can cause high-intensity sparking, so careful maintenance programs are necessary to prevent rust. The section ends by stating that the use of the standard in no way implies a guarantee of safety, and it's because so many other things matter, such as the installation of the fan and the maintenance of the fan. You can also see now how spark resistant will also affect the fan arrangement that you use that we discussed in the last video. You can always contact your Norman S. Wright salesperson if you ever have any questions about this or any of our other weekly topics. Let's pull this back on screen, and maybe I'll move this over a little bit so I can get it a little bit bigger. So that's spark resistant construction for fans. Don't forget to subscribe to our YouTube channel, and thanks for watching.